In this section, we will explain some of the trends in the periodic table. So the learning objectives of this section are to describe the trends in reactivity in Group 1 and Group 7. So we will describe the reactivity of the elements in Group 1 and those in Group 7, and to explain how electronic structure can explain trends in reactivity in these groups. So actually, we will examine the electronic structure of elements in groups 1 and 7 to explain the trends in their reactivity. In previous sections, we have seen that elements get more reactive going down the group. So as we move down the group from lithium to sodium to potassium, elements will get more reactive. So if we want to compare, for example, between the reactivity of potassium and lithium, potassium is more reactive than lithium. And actually, the opposite trend is observed in the group 7 elements. So in group 7, we have fluorine, chlorine, bromine, and iodine. Iodine is less reactive than bromine. We will explain these trends by examining the electronic structures and how the atoms tend to lose or gain electrons in their reactions. So as we go down a group in the periodic table, so we are moving in this direction, the number of shells occupied by electrons increases by 1 extra electron shell per period. So as we know, these are periods in the periodic table. As we move from one period to another, we will add 1 more electron shell. And as the number of these electron shells increases, the atom becomes larger. So as we move down the group, the atoms become larger. And this means that potassium is larger than lithium, and an iodine atom is larger than a fluorine atom. Actually, this has two effects. First of all, larger atoms will lose electrons more easily as we go down a group. So as we go down a group, it will become easier for the atom to lose an electron. And larger atoms gain electrons less easily going down a group. So as we move down a group, it will become harder for the atom to gain an electron. Keep in mind that atoms lose or gain electrons into their outer shell, so to the most outer shell. Let's start with explaining the trend in Group 1. Here are the elements of Group 1. Elements in Group 1 of the periodic table are known as alkali metals. For example, we have lithium, sodium, and potassium, etc. As we move down the group, the atoms get larger because they have 1 more electron shell. So let's examine the electronic structure of lithium and potassium, for example. Lithium has an atomic number of 3, so it has 3 electrons, whereas potassium has 19 electrons. These are the electronic structures. Notice that both elements, lithium and potassium, have only 1 outer electron in the outermost shell. Between lithium and potassium, this electron of potassium is attracted less strongly to the positive nucleus. We know that the nucleus holds a positive charge due to the presence of the protons. And there's attraction between the electrons and the protons. However, as the distance between the outer electron and the nucleus increases, the electrostatic attraction with the nucleus gets weaker. So as we have more electron shells, the distance increases and thus the electrostatic attraction becomes weaker. In addition to that, this outer electron experiences a shielding effect from inner shells of electrons, so from electrons in these inner shells which are near to the nucleus. And this reduces also the attraction between the oppositely charged outer electron and the nucleus. Actually, you may think that as we move down the group, the atomic number increases and thus the positive charge of the nucleus will increase as well. because more protons are now present inside the nucleus. So if we want to compare the nuclear charges of lithium and potassium, here we have 3 plus and here we have 19 plus. This may suggest that the attraction for the outer electron should get stronger. However, pay attention. The greater distance and the shielding effect of inner electrons outweigh the increasing nuclear charge. So actually, to change from lithium to lithium ion Li+, so to lose this electron, it takes more energy than to change from potassium to a potassium ion K+. So because this electron feels less attraction, it will be easier to remove than the outer electron in the lithium atom. And thus, potassium is more reactive than lithium. So this is why elements in group 1 becomes more reactive as we move down the group.